Good evening, everyone. I would like to extend a warm welcome to all of you who have joined us today for the webinar on Kickstart to Robotics, organized by the IEEE Techverse Sri Lanka.
Recording in progress.
With the collaboration with the IEEE Robotics and Automation Society of Wellassa University, along with the Circuit Breakers Robotics. To begin with, I am Tarashidhar Mistry, a member of the secretary team of IEEE Techverse Sri Lanka, and I will be your moderator for today's session. Today marks the third day of the 4-day webinar series that aims to give you an introduction to robotics. Today's session will be conducted by 3 speakers with the hope of talking about debugging tools, batteries and their characteristics, and voltage regulators with a practical session at the end. If you missed previous sessions, you can watch them on the IEEE Techverse Sri Lanka Facebook page and YouTube channel. The last session will be held tomorrow, so I invite all of you to stay until the end of the session. Keep in mind that if you attend all 4 sessions conducted for this series and fill in our feedback forms, and then you will receive a certificate of participation. If you have any questions during the presentation, please feel free to type them into the Slido link, and I'll be bringing them during the Q&A session, which will be conducted later. Now, I would like to welcome our speakers for today's event. Rana Rigurasinghe from the Department of Electrical Engineering, University of Moratuwa. Shamida Liyanage from the Department of Electronics and Telecommunication Engineering of University of Moratuwa. And Himanshu De Silva, Department of Electronics and Telecommunication Engineering of University of Moratuwa. We are deeply honored and privileged to have you here with us today. With that, let me invite today's speakers to take the virtual stage and start you off on this journey of robotics. Over to you.
Good morning and good evening, sorry. And I hope my screen is visible to you. Can I please get a confirmation?
Yes, it's visible.
Okay, cool. Yes, so this in today's session, in the past few sessions, you all have learned about introduction to robotics and also regarding potentiometers and basic introduction to robotics. So without further ado, let's proceed with what we have to learn today. So I'll start off with regarding how to measure distance when we are doing Arduino or a Raspberry Pi project, or if we are making a robot. So if we are making a robot or maybe a project, I guess we have the urge to measure the distance, or at least to find out whether there's an object or not in the range that we are using the robot or the project. So what do you mean by the distance measuring sensors? What do you mean by distance measuring? So basically, why are we using sensors as well? So we can use a physical device such as a measuring tape or a ruler to figure out the distance that from the object to from the object itself, but we're using sensors for it. So distance measuring sensors is basically measuring distance without a physical object, so without a physical device, physical contact. So if we consider about distance measuring sensors, so we can categorize into several different types. So one of those is output waveform. So we can categorize into 2 different parts, which are analog and digital, based on the output waveform that we get. So you all know what analog and digital are. So if we consider about digital signals, we only get two outputs, either 1 or 0, or else high, low, or 5 and 0. So something like that, we only get two digital outputs. But if we consider analog outputs that we get from sensors, we get outputs in a wide range, not only just two outputs. So either depending on what we need in our project, we should first identify what is the output that we should get. Maybe if we might need to get whether identify whether object is there or not. So for that we can use a digital signal. But if you want digital a sensor that gives digital outputs. But if you want to measure the distance, the proper distance to an object, we should use an analog sensor. So we should first identify which sensor to use in our project. And then, so as I said before, so we can categorize the distance measuring sensors into various categories. So one of the categories is output waveforms, and then we can differentiate that in as a working principle as well. So let's see what working principles that we use in distance measuring sensors. So as you all can see, we will talk about three working principles in today's session. So one thing is measure intensity, and then we have measure time of flight and measure incident angle. So as you can see in here, yes. So as you can see in the measure intensity, what the sensor basically do is it emits an IR or the infrared. It emits an IR, and then that infrared reflects on the object, and using this proximity center or the photodetective sensor, it receives that infrared. So based on the intensity of that particular IR or the laser, it measures the distance which has from the sensor to the object itself. So that's one of the principles that are currently used in the distance measuring sensors. So measure intensity is one of those. And when we consider about measure time of flight, what it basically does is it also emits either ultrasonic or IR, and then it basically measures the time that it receives. It measures the time that it takes to receive the emitted signal. So based on that, it measures the distance. And let's see how we can do that. So I'll be explaining more on this working principle later on when we are talking about the ultrasonic sensor. And the other principle that we use is measure incident angle. So as you all can see in here, sorry for that. So there's an LED, and also there is this PSD, so or the position sensitive IR detector, which is known as PSD. So in the LED, it emits the infrared, it emits the IR, and then so there's a P1 object and also there's a P2 object, as you all can see. So when the LED emits the infrared, and when it comes to P1 object, it reflects back, the infrared reflects back, and it comes to U1 position. So as you can see, there's an angle between these two lines. So based on that angle, we can measure the incident angle. So based in trigonometry, we can also measure the distance that we have from here to here. So from the LED sensor to the P1 object. So likewise, so we can measure the distance that we have to the P2 object as well. So these are the working principles that we are currently using in the distance measuring sensors. So measure intensity, so basically measure the distance by using the intensity of the emitted infrared and the received infrared. And then we have the measured time of flight. So it basically, we can measure the distance using the time that it takes to receive the emitted signal. And also we have the measure incident angle. So there are three working principles that we are currently using in the distance measuring sensors. Yes, so when we choose a sensor for the project, or if you're making a range, we have to look at these characteristics definitely. So those characteristics are range, resolution, accuracy, and precision. So when we talk about range, so range is really important factor when we measure the distance, or else when we not only distance measuring, but also when we take any other sensor, let's say PIR sensor or the temperature, humidity sensor, we have to consider about this range. So range is basically the particular, let's say, when consider about the distance, the particular distance that we can get the values from the sensor. So if I talk about the ultrasonic sensor, which is HCSR4 sensor, so the range of that is the practical range of that particular sensor is 2 centimeters to 80 centimeters. So we can't measure more than 80 centimeters or less than 1 centimeter or 2 centimeters. We cannot detect out of those range. So range is really important because we might need to measure around more than 1 meter in our project. So if you are going for that, we cannot use the sensor that I talked about before. So we have to consider about its range. Really, so the range is really important factor, as I said. And then we have to check the resolution as well. So does anyone know what resolution means? Does anyone know what resolution means? Can I see some answers in the chat? Anyone? What does resolution means? Okay, as we will be late for the other sessions that we are conducting today, I'll move on. So resolution means is the smallest value that we can detect from a sensor or detect from any other device. So resolution means that the smallest value that we can get. So if we consider about the ruler, we can just measure the 1 millimeter on it. So we cannot measure something less than 1 millimeter in the ruler. So likewise, so there is a small measurement. There's a what? We can only measure a certain value in the sensors as well. So we cannot measure just like we cannot measure less than 1 millimeter in the ruler. So likewise, we have that in the sensors as well. So we have to consider that as well when we, when we choose a sensor for the project. And also we have to consider about the accuracy and precision as well. So let's see what accuracy and what precision is. So y'all can see these dartboards. So I'm pretty sure you might have played darts. At least you have seen a dartboard as well. So in the dart game, what you all have to do is basically point out to that middle point. So point the dart to the middle point. So that's how the game goes. So in the in the first picture, all the darts are in the center position, as well as all 5 darts, all 6 darts is in the same position. So that means it is in the high accuracy and high precision. So it's close, it's in the center itself, so it's accurate, and all the 6 dots is in the same position. It's closer to the same position. So that means it's in high precision as a high precision position as well. So when we consider about the second one, so as y'all can see, the 6 dots are in together. That means it's in high precision, but it's far away from the center. So that means it's low accuracy. It's not accurate. The place that we have sent the dots is not accurate. It's not in the center. So that means it's low accuracy. And when we talk about the third picture, so it's all the dots are in the are close to the center, but it's not close. All the 6 dots are not close to each other. So it's high accuracy and low precision because it's in the center itself. Its accuracy is high, but as the dots are not all together, it is low precision. And when we talk about the fourth picture, it's like all the dots are not close to each other, and it's also not in the center itself. So that means it's low accuracy and low precision. So when we so I'm pretty sure like you might wonder like, why are we talking about dots in a sensor session? So when we talk about when we have to choose a sensor, we have to identify whether that sensor is accurate or not. So if we are using a sensor for a certain amount of time of period, the sensor might not get precise or might not get accurate enough for us to do the project. So that's why we need to figure out whether it's accurate enough to proceed with the project, or whether the values that we get are precise. So for an example, if we get if the distance to an object is 50 centimeters, and if we get some values like 48, 49, and 52, it's precise. But if we get a value like 29, or if we get something like 1 meter or 100 centimeters, that is not accurate because it's far away from the real value that we should get. So that means it's low accurate. So we should figure out that too as well when we are choosing a sensor. So range, resolution, accuracy, and precision, those characteristics are essential factors when we are choosing a sensor for a project. And yes, so we're talking about distance measuring sensors. So there are 4 available sensors that we can use in order to measure distance. So those are IR and proximity, sharp IR, TOF sensor, which stands for time of flight, and then we have the ultrasonic sensor. So distance measuring sensors and proximity sensors are different. So proximity sensors are basically used to identify whether an object is there or not, to detect whether an object is there or not. So, and the distance measuring sensors are used to measure the distance. So proximity sensors are used to detect whether an object is there or not, and distance measuring sensors are used to measure the distance. So let's see one by one what are the characteristics and how we can use, and what are the working principles that are being used in these sensors. So yes, so first one is IR and proximity sensor. So in this IR and proximity sensor, this is the IR sensor, and this is a proximity sensor. So IR and proximity sensor is basically used for obstacle detection. There are various applications that we can use to, maybe if you're using a robot, we might need to identify whether a wall is there, or whether to measure whether the floor is black or white, or black or any other color. So in order to figure that out, we are using the IR sensor. Or if you want to detect whether an object is there, we can use a proximity sensor as well. So in the IR sensor, what the working principle is the measuring intensity. So basically, that is the working principle. So we have the IR emitter, which is the white LED, and we have the IR receiver, which is the black LED. So why we are using black? So if you are using black, so that can absorb many of the light that has been reflected or that has been emitted from an object. So that's why we are using a black LED for the IR receiver. So in the measuring intensity working principle, so it emits infrared, and then it reflects back that infrared, and then the IR receiver or the position sensitive precision depth sensor, or the PSD, receives that particular sensor. So that's how that IR proximity sensor works. So based on that intensity, the resistance value and the voltage differs. So as you all can see, this is a potentiometer. So based on that, based on the intensity of the infrared, the resistance and the voltage differs. So based on that, we can get the output. So this is the IR sensor, or the we use for that. So this is one of the IR sensors that we use, and so IR sensors are basically used for many of the applications. So you all have seen, I'm pretty sure you all have seen the line following robots, where the robot, we practically code the robot to go on the black line. So if it detects a white, white flow, it turns to where the black path is. So that for that application, for that robot, the infrared or the IR sensor is particularly used. So let's see what we have a video clip for you. So let's see how we can use IR sensor for that particular application. Yes, so as you can see, the robot only follows the black path. So in order to do that, we have used the IR sensor. Okay, so we have talked about the IR and proximity sensor, and now we will talk about the sharp IR. So in the sharp IR sensor, the incident angle working principle is a working principle that is being used in the sharp IR sensor. So that means it, the infrared goes up to the object and it reflects on a certain angle, and that angle can be measured using that sensor. And with that angle, it can measure the distance. So that is the working principle of the sharp IR sensor. So in the sharp IR sensor, we can get a wide range of values. So we can measure a distance. So in here, you all can see various types of sharp IR sensors, and the range really differs. But as you all can see, so in the previous example, as I said, we can, in the ultrasonic sensor, we can only measure up to 80 centimeters. But in this sensor, we can use for around 150 centimeters. So that is one of the advantages that that's in sharp IR sensors. So and also this this sharp IR sensor can be can be measured to measure distance of that has complex surfaces, or maybe rough surfaces or smooth surfaces. It does not really depend on the type of the surface that we have in the object. So we can measure an object that has a rough or a smooth surface as well. So, and these sharp IR sensors are widely ranged, widely used in the application. So maybe in TVs, computers, laptops, it's widely used, the sharp IR sensors. But as I said, so in the sharp IR sensors, it is affected by environmental conditions, so such as if there is fog, or if there's smoke, there will be the distance measuring will be affected. So that is one of the disadvantages that we have in the sharp IR sensor. So it is the sharp IR sensor, the advantages are it can detect in wide, it can be used in a wide range of area to detect the distance, and also it is using the incident angle measuring type. So yes, so this in the previous IR sensor, so it basically measures based on the intensity. So in the sharp IR sensors, as we use the incident angle type, it does not really affect on the intensity of the object, intensity on the reflected infrared. So that is what we are using. So in here, in the black one, we have the object is a white paper, and in the gray, in the dotted lines, we have the gray paper. So as you all can see in the graph, it really does not differ. So if you use the previous IR sensor, this graph will not come. This graph will be hugely differs. But as we are using this sharp IR sensor, which uses the incident angle measuring working principle, we get the same values for the white paper and the gray paper. So this sharp IR sensor does not really depends on the color of the object that we have. Yes, and this.
Recording in progress.
We place the object that we want to scan in the middle. The distance sensor is placed on the z-axis, which can move up and down. We measure the distance to the object, and with that data we can calculate the x and y coordinates and save those on an SD card together with the z coordinate. So here is how we will do that. The sensor measures the distance to the object. That's pretty easy, right? Then the turning table spins one more step and measures the distance once again. The x increment is the sinus of the rotated angle called alpha in this case, multiplied by the hypotenuse. In this case, the hypotenuse is the full distance between the sensor and the center of the rotating table minus the measured distance. The y-coordinate is the same thing but using the cosine of the angle. The angle is given by the step motor, because each step represents 1.8 degrees, since a full rotation needs a total of 200 steps.
Yes, so Yes, so that's how the sharp IR sensor is used in this particular application. And so that working principle, or the incident measuring working principle, is also known as triangulation, because we measure the angle using, the triangular method or using trigonometry. So that is why it's called as triangulation as well. So we have talked about the IR and proximity sensor and also about the sharp IR sensor. So now let's see what these TOF sensors are. So TOF sensors stands for time of flight. So it basically uses the time that it takes to get back the reflected signal. So we emit the signal and it measures the time that it get backs the reflected signal. So that is how it goes. So in the TF sensors, so there are several pins. So VDD, V input, where we give the input, and then the ground pin and the SDA, ASCL, and the output pins. So just likewise, we have several pins in here. And so this is the TOF sensor. So in this TOF sensor, basically the transmitter emits the laser light and it targets the object, and then that particular laser is reflected by the target object, and the distance is calculated by using the S equals ut, or the distance is equal to velocities times time equation. So that can be calculated. Yes, so there are several applications in this time of flight sensors as well. So this also has a high measurement range, and also, but this time of flight sensors is a little bit expensive. So the sharp IR sensor and time of flight sensors both are a little bit expensive. So it is expensive in comparison to ultrasonic sensors, which we will talk about later, and also the IR sensor, which I talked about in the first few slides. So yes, with that, so we will move on to ultrasonic sensors. So I guess you all have seen this sensor very oftenly. So this ultrasonic sensor is so there are 4 pins in this ultrasonic sensor, which is voltage, and then we have the ground pin, and then we have the trigger pin, and then we have the echo pin. So if we consider about the working principle, so we put 5 volts to this VCC pin, and then 0 volts, or we ground the this pin, and then we have 2 pins left. So we have trigger pin and echo pin. So if we want to measure a distance, we basically give a high voltage or a 5 volts to this trigger pin. So with that, the sensor knows, yes, we have to measure the distance, and then it gives back 8 40 kilohertz pulses to the sensor, and it's being transmitted. So as this is 40 kilohertz, that's why it's called ultrasonic. So we cannot, it's unhearable for the human frequency, human ear. So that's why it's called ultrasonic. So it sends back 8 40 kilohertz pulses are transmitted when we give a high voltage to the trigger pin. And then, so it goes back, it emits the ultrasonic sensor, and then it reflects back, and then it receives. By this, it receives back that ultrasonic wavelength, and then we get the output based on the distance that we get. So yes, so let's see how we can calculate this as well. So as the sound of the wave, the velocity of the sound wave is 340 meters per second. So we have the equations: time is equal to distance divided by speed. So as you know, it takes, so if we take t as the time it goes from the sensor to the object, the time that the sensor collects is equal to t, because it goes back and it has to come back as well. So that total amount is calculated by the sensor. So we get this, if we say the time that, if the distance is 10 centimeters, we get the total time is as 294 microseconds. But if we have to calculate the distance, we have to divide it by 2. So that is the working principle of the ultrasonic sensor. So we have to give a high voltage to the trigger pin if we want to measure a distance. So ultrasonic sensor is widely used in robotics. So if you want to measure it, as it's cost effective, it is basically used in all the projects that are currently like in the student level and student level. So yes, so there are several advantages of ultrasonic sensors as well. So before that, let's see what are the characteristics or what are the sensor features that we have in the HCSR04 ultrasonic sensor. So the operating voltage is 5 volts, and the theoretical measuring distance is 200 centimeters to 450 centimeters. But that's only the theoretical measuring distance. But if we are using it in the practical, we only get around 2 centimeters to 80 centimeters. And the accuracy or the resolution is 3 millimeters. And then the measuring angle is covered is less than 15, and the operating current is also less than 15 milliamperes. And the operating frequency is, this should be 40 kilohertz. Yes. Moving on, so the ultrasonic sensor, as I said, there are several advantages and there are several disadvantages of this particular sensor as well. So as I said, cost is less, so it's cost effective. So if you are making a robot, or if you are doing some certain of project, it costs a lot to for us to build that with all the components that we have to get. So, but if you're using ultrasonic sensors in comparison to all other distance measuring sensors, it's it's cost effective, and it also has a wider field of view. So as I said, the measuring angle is covered is less than 15 degrees. So it has a wider field of view as well. And it is also insensitive to hindering factors such as light, dust, smoke, mist, vapor, and glint. So if we use an infrared sensor, basically that IR sensor is sensitive to all of these factors. That IR sensor is the values that we get from that IR sensor basically differs from the actual value if there are lights, dust, and smoke in the midway. And it's also not, the ultrasonic sensor is also not affected by the object color or transparency. And then if we consider about the disadvantages or the cons, this cannot be worked in a vacuum. So as y'all know, there should be a media or a medium to pass the sound. So the sound doesn't pass through a vacuum. So there should be a medium in the pathway that we have to detect the object. And this ultrasonic sensor is also not designed for underwater use. So if we are, doing a water-based project, or if we are creating a project that, if we are creating a robot that is that has to be used in underwater, we cannot use this sensor as well. This sensing accuracy is affected by soft materials. So this, ultrasonic sensors differs from the surface as well. So if there is a rough surface or if there's a smooth surface, the values that we get differs even if the object is in the same distance from the sensor. And it also have a limited detection range. So as I said, there is the practical measuring distance is 2 centimeters to 80 centimeters. So it has a limited detection range. So sensing accuracy affected by changes in temperature of 5 to 10 degrees or more. So the sound, the velocity of the sound is affected by the temperature as well. So if even if the object is in the same distance from the sensor, if the temperature goes high or low, it can, the value that we get can change. And also it has a slower response, so it's not suitable for fast moving targets. So if a person is walking by, or if we have to, detect an object that is moving, we cannot use this sensor as well. Yes, so let's see what we have in this video. So this how the working principle of CSRO4 is also is explained in here. So this is the HCSRO4 ultrasonic sensor. So it basically moves according to the hand movement of that person. So we can code the entire project in order to do that. Yes. Yes, so that with that, the distance measuring sensors section is over. So I hope you got a basic idea of which sensor to use in your projects if you are doing so. And let's now talk about displays that we should do. So if you want to, pass a message, an error, if an error message needs to appear, or if you want to see what is the temperature of the room, if you want to see whether there is an obstacle in front of the sensor or not, we can use these displays to, to display that particular, particular value or the particular thing that we needed. So there are several types of displays. So OLED, OLED, this LCD display, and the 7-segment displays, and the dot matrix. So this OLED is, it's newly introduced to the field. And then we have the LCD displays. So these are used in so many applications. So if you take a calculator, there are LCD displays in that as well. And then we have the 7-segment displays. And then we have the dot matrix, the LED lights that we see maybe in restaurants, hotels. This LCD displays, the dot matrix display is used. So the displays are also can categorize into various categories, various types, depending on the technology and maybe the screen color or the interaction method we can do. So if you take about the screen color, there is the color screen, which is in the OLED screen. And then we have the monochrome or the black and white screen that is using LCD displays. And then we have the interaction. So there are touch screens using phones and, several laptops. And then we have the non-touch, they are using, normal TVs, not smart TVs, using normal TVs. So there are touch and non-touch based on the interaction, and then we have color and monochrome based on the screen color as well. And then the LCD, if you talk about LCDs, so why I'm talking about LCDs specifically, because this OLED or the OLED is kind of expensive. So basically in the projects that we are currently doing, the LCD displays are widely used. And that does not mean we cannot use OLED as well, but as LCD displays are widely used, so I'll be talking about that. So LCD displays can be found in various sizes. So based on your project type, based on the area that you can give to this particular sensor, you all can choose whatever the LCD display that is available in the market in various sizes. So, there are several sizes available in the market. And then if we talk about the pin configuration, so there are 16 pins, which is quite a bit of numbers. So we have VSS, and then we have VDD, which VSS stands for ground. And then we have the VDD, or the pin that we should give the 5 voltage. And then we have the third pin as the, the pin that we can change the contrast of this whole display. So we can change the contrast according to the value that we give to this third pin. And then we have 4, 5, 6 as, read, write, enable, and the register pins. And then from 7 to 14, we have 7 pins, 8 pins as data pins. And then we have 15 to LED positive and 16 to LED negative. So these 2 pins are used to lighten up this LCD display. So there's a backlight in the LCD displays if we on it. So in order to do that, we give this LED positive and LED negative the values that we should get. And then, so as I said, there are 16 pins in here. So if we give all these 6 pins to the Arduino board? So in Arduino boards also, like there are, if we take about Arduino Uno, there are less number of pins as well. So if we give the values to these 16 from the Arduino itself, it takes a lot of it occupies a lot of pins in the Arduino board. So for that, in order to reduce the number of pins that it is going to give to the Arduino pin, we use this I2C. So this y'all can do your own research in I2C, because so if we talk about these I2C, there are 16 pins as well, and the output that we can give is there are only 4 pins. So we have ground, VCC, SDA, and SCL. So SDA stands for data line and SCL stands for clock line. So as there are lesser number of pins in this I2C, we can simply connect it to the Arduino board with all the other components that needs to be connected to the Arduino Uno as well. So this I2C is really needed if we are going for this LCD display, because if we are straightly connecting this LCD display with the Arduino Uno, it takes a quite number of pins. So in order to make it lesser, we are using this I2C pin as well. Yes, so with that time at the end of my section, so I'll be handing over to Chamidu to continue with the session. Yes, thank you.
Yes. Am I audible, and can you see my screen?
Yes, you're audible and visible.
Okay, thank you. First of all, sorry if there's any lag, because I'm facing a power cut. Okay, so let us begin. I will be covering robot power and batteries. So robot power is one of the main subjects that we need to learn when it comes to robotics. Why is that? Because not even robots, as humans, we also need power, right? If we want to when we do daily activities like studying, sleeping, running, like that, we consume power. So how do we get the power, get the energy that we needed to do those activities? We simply eat, right? So that's how we generate power. Similarly, in any other maybe electronic device or any other living creature, they also need power. And when it comes to robotics, it is mainly supplied through electrical power. So electrical power we can give electrical power to robots in 2 such ways. One way is by directly connecting the robot into our main power supply. I mean our home supply to 30 volts AC supply. Other way is to connect batteries. So what are the pros and cons of those two methods? Let us discuss that. Okay, so if you are going to connect your robot to the power supply that is given to your home, then what are the advantages and disadvantages of doing such thing? First of all, most robot components like motors, sensors, they don't work with AC power. So if you directly connect your maybe Arduino or motor to the AC power, then most probably your component will get burned and damaged. So that's not advisable. So what we can do is we can use power adapters and voltage regulators. So those, I think voltage regulators we will cover in this session. And so what we do in those circuits is we rectify the signal. As you know, we have AC signal. First of all, we step down that to 12 volts, then we rectify the signal, and then we use adapters to get a DC voltage. Then we give the power to our robot. That's one way. And the other way is to directly connect batteries. With that, without using any adapters or such things, we can directly give DC power to our robot. So one advantage of using grid power, I mean power from our home, is that we don't need to replace batteries. Normally batteries die out, we need to recharge them. So without all those troubles, we can simply connect our robot to the power and we can use them. So but the main disadvantage of that is the range of the robot will be limited, because like we need to connect it to a outlet. So it has to be either wire or something like that. So the range of the robot will only be the range that we can travel with the wire cord. So that's one main disadvantage. And also like if we are going to use our robot in outdoors, that will also be a problem, because like mostly power outlets are indoors, right? So those are the disadvantages of using grid power. So if you guys are designing a robot which doesn't move much, like let's say a robot arm, so it stays stationary and only the robot arm will do some movements, it is very limited. So for such kind of robots, you can use grid power. Otherwise, if your robot is a mobile robot, like normal, like let's say line following robots, and then as I showed you guys earlier in the first week, let's say Roomba robot and then Boston Dynamics robots, those kind of robots need to have a separate power, so they need to have batteries. So our main focus in this session is to talk about batteries, and so let's dive into it. So first of all, we need to understand the characteristics of a battery. So there are mainly 6 characteristics named as terminal voltage, nominal voltage, capacity, discharge rate, charge rate, and charge cycle. So I will be going through one by one those characteristics. First of all, let's take terminal voltage. Terminal voltage is the voltage which is or let's say the difference of potential between the battery to what we call difference potential difference between anode and cathode of the battery. So it can vary. So here you can see a battery. Here it says 11.1 as the voltage. So this is what we call the nominal voltage. It's the second characteristic. It is the voltage which is specified in the battery itself. So as you can see here, it's 11.1. And if we take a battery from your nearby store, we know we have AA, AAA, and then single A batteries. Those batteries have the nominal voltage of 1.5 volts. So we use them as like in our TV remote, in our clock, like that. So that is what nominal voltage is. It is the specified value in this battery. The terminal voltage is the potential difference between anode and cathode, and it might vary according to the charging situation of the battery. If a battery is fully charged, then normally the terminal voltage will go high. Like let's say if it's a lipo battery, the terminal voltage when the battery is fully charged is around 12.6 volts. So I believe you now understand what is the difference between terminal voltage and nominal voltage. So the advantage of this battery is, yes, it may vary. The voltage may vary from like 12.6 to it even goes down from 11.1 when the battery is discharged. But for most of the time, when we use the battery, it normally stays at 11.1 volts. That's why we specify this 11.1 volts as the nominal voltage. So yes, those are the first two characteristics. Then let's move on to capacity. So capacity of the battery is the number of charges, number of positive or negative charges which is stored in the battery. So if we take, for example, let's take a tank, water tank. So we can specify the capacity of that tank by saying that it can hold, let's say, 2000 liters of water. So 2000 liter is the capacity of that water tank. Like that, there the measurement is, the unit that we use is liters. Here, the unit that we are using is milliampere hours. It is basically a unit which resembles number of charges. So I believe as students, you know what is the unit that we use to measure charges. It is coulomb. So this milliampere hours is also a similar unit to coulombs. What it reflects is what this value reflects, this capacity. It reflects what it says. If we use the battery for an hour, okay, so if we use the battery and take 2200 milliamperes or 2.2 amperes constant current throughout the time period, we will be able to power up our robot or power up our other device for 1 hour. Okay, so if we use 2.2 amperes constant current, then we will be able to power up our device for a period of 1 hour. So what happens if we like increase the current? Let's say we draw a current of 4.4 amperes. So if we use a 4.4 amperes constant current, then the time that we can use our battery will reduce to half an hour. Okay, so what this capacity means is the current that we are using multiplies by the time that we use. Okay, so this is the capacity. So if you want to find out how much time that we can use a battery, if you know the current that it will take, then you can calculate the time duration that you can use the battery using capacity value. So I hope you understood what capacity is. Then we have discharge and charge rate. So what discharge and charge rate means is, discharge rate simply means how fast our battery is discharging. So going into the previous example of water tank, if we like turn on a tap, then the water will flow at some rate. Let's say 1 liter per minute. So that is our discharge rate of that water tank. And now if we like use another tap and fill up the tank, then let's say the water is filling at 0.5 liters per minute. Now that will be the charge rate of the water tank. So discharge rate is uh, if the current is passing through the battery. If the charges are taken away from the battery, then we say the battery is discharging. If the charges are going into the battery, then we say the battery is charging. So usually the units that we use to determine the discharge rate and charge rate is amperes. As you know, I believe you know this equation, Q equals IT. So here the Q is the number of charges and I is the current and T is the time. So if we take out I, then we can say I equals Q divided by T. So that is the rate at which charges are going out. So amperes is the base unit for discharge rate and charge rate. But for batteries, we define another unit, that is the C rating. So in a battery, you don't see something like 20 amperes discharge rate and 2 ampere charge rate like that. You see the C rating. So here you can see 20C. 20C is the discharge rate, and here you can see also 2C as the charge rate. Normally the discharge rate is higher than the charge rate. Okay, so now let's see what this C rating means. So how do you calculate? So as I said earlier, discharge rate resembles the current that we can draw from the battery. So how do we calculate the maximum current which can be drawn from the battery? So if you take a battery, if you take any battery, there will be a maximum current which the battery can provide. So to calculate that, what we do is, first of all, we need to convert this capacity. So in this capacity, you can see the units is milliampere hours. First of all, we need to convert this into ampere hours. Okay, the first step is to convert these milliampere hours to ampere hours. So what do we do to convert milliampere hours to ampere hours? We simply divide this value by 1000. So the capacity that we will get will be 2.2 ampere hours. Then to get the maximum current, okay, to get the maximum current, so battery can provide less current specified than this. So what we here calculate is the maximum current the battery can give. To get that, what we do is we multiply it by this C rating. So it will be minus 20 multiplied by 20. Here we will get 44 amperes. And this will be the maximum current the battery can provide. Okay, so you simply, when you are given the C rating and the capacity, to calculate the maximum current the battery can provide, what you can do is, first of all, convert the milliampere hours value to ampere hours by dividing it by 1000, then multiply it by C rating. Then the value you will get is the maximum current the battery can provide. Similarly, here the discharge rate is given as 2C. So what you do is, you first convert this capacity to ampere hours, that will be 2.2, and then you multiply it by 2. Then you will get 4.4 amperes. So the maximum current that we can give to charge this battery will be 4.4 amperes. So if you give higher voltage, higher current than that, the battery will get damaged. Okay, so you need to be careful of that. Then the final characteristic that we need to consider is the charge cycle. What charge cycle means is, so charge cycle is related to rechargeable batteries. So in a recharge, we know that even in laptop batteries and even in phone batteries, even though they are rechargeable, they will not last infinitely. At some point, our battery will die out, right? So if it's a phone battery, we know it will die out in 2 or 3 years. Then we need to remove that and replace with a new battery. So why does it die out? The main reason is the charging and discharging cycle. We know when we use the phone, the battery will get discharged, and then we connect it to the power supply, then the battery will recharge. So if we fully charge the battery, and if we use the battery until it's fully discharged, that is a one cycle. Okay, so if we charge the battery from 0 to 100, then it will be a complete cycle of charging. So this charging cycle says how many number of cycles we can charge our battery. So that is what the charge cycle means. So I hope you got all those characteristics of a battery. So, and why do we need this? So we need this because for several robots, for the robot that we are going to design, we sometimes need to consider the current. I mean, if you are using a drone, okay, if you are building a drone normally requires a larger current to operate. So we need to, then to power up that drone, we need to use a battery with higher C rating. That's the importance of capacity. And if you want to charge your battery at a faster phase, then you need to use a battery with higher charging rate. And if you want to use your battery for a longer time, imagine a robot which operates whole day, then for such things you need to use a battery with higher capacity. And then also, this is the most important one, some electronic components such as let's say motors, they don't operate at 5 volts. Usually we can't operate our motors at 5 volts. We need to supply it between 6 and 12, maybe even higher than that. So that's when this nominal and terminal voltages comes. Okay, so if we want to power up a robot, we can't use 3.7 single cell battery. We have to use either 7.4 or 11.1 battery. So and when according to the robot that you are building, you need to consider all these characteristics in order to choose a better battery for your robot. Okay, then let's go to the connections of multiple batteries. How can we connect multiple batteries? There are mainly two ways to connect a battery. First is series connection, and then we have parallel connection. So why do we use series connection and why do we use parallel connection? In series connection, what we do is we connect batteries like this. So we connect the positive terminal of one battery to the negative terminal of the next battery, and so on goes the chain. Okay, so positive to negative, positive to negative, positive to negative, and this whole system's positive terminal will be this, and whole system's negative terminal will be this. So you can see this kind of configuration in your TV remote. You know, like we use two AA batteries, two I believe AAA batteries to power up the TV remote, right? So it needs 3 volts. To give that, we use two 1.5 batteries in series. So as I mentioned, in series connection, what happens is it adds up these voltages. So here we have used 4 3.6 volt batteries. So what this does is, this gives the total of 14.4 volts voltage to the circuit. Okay, so yeah, if you have like, let's say now in the previous example, you need to power up your motor, which takes 6 volts, like 6 to 12 volts. But you only have 3.7 batteries, 3.7 volt batteries. So what you can do is you can combine 2 or 3 batteries to get either 7.4 volts or 11.1 volts. And then you can use the combination of that batteries to power up your motor. Okay. So in series connection, as I mentioned, the voltage value increases, but the capacity will not increase. So if you are using 3400 milliampere hours batteries, the capacity will remain unchanged. Okay, in series connection, we can't increase the capacity, because if a single charge is dismissed from this battery, this end, then it will go through all these batteries. So because of that reason, we can't increase the capacity, only we can increase the voltage value. Then in parallel connection, other way happens. So if we want to increase the capacity, so if we want to use our robot for a longer duration, but we change the voltage. And here, especially in parallel formation, you need to be careful to connect batteries with similar voltages. So the reason is, if let's say now you can see all 4 batteries are in 3.6 volts. If we connect like let's say 5 volt battery here, then what happens is it gets discharged and the other batteries will get charged. So what we want to do is get the current out from this circuit, but what happens is, if we connect a 5 volt battery instead of this, is the current will flow from this battery to other batteries. So instead of discharging and giving power to the robot, these batteries will get charged, and this battery's energy will based on charging these other 3 batteries. So be very careful when you use parallel connections to set up the batteries. Always remember, you need to use the batteries with similar voltage values. Then, so what if we want to increase both voltage and capacity? Then we can do these kind of connections. Now, these kind of connections we call as combined connections. Here you can see there is also series connections as well as parallel connections. So here what happens is 2 batteries are in series. Therefore, the terminal voltages of this circuit, this system will be 7.2, and the capacity will be also, there are 2 batteries in series parallel. So the capacity will be 6,800 milliampere hours. Okay, so according to your application, you can connect your batteries in series or in parallel, or even we can combine them and put them in such a way. So now let us dive into some categories of batteries. What kind of batteries that we use in robotics? So first of the first category that we can talk is dry cell batteries and wet cell batteries. So what wet cell batteries means, we use some kind of liquid in the battery. So this is what we call a simple cell battery. Here we use a zinc and copper plates, and we use H2SO4, that's sulfuric acid. So if you connect this kind of circuit, then from zinc to from copper to zinc, there will be a current flowing. Okay, so this is the simple cell battery, and it contains a liquid, right? It contains sulfuric acid. And also, I believe if you know about cars and if you know about the older batteries, there are car batteries where I believe you have heard about battery acid, right? අපි කියනවා battery වතුර මාරු කරනවා කියලා කියන්නේ. Okay, so there in these kind of batteries we use battery acid. So from time to time we need to replace those acid. So those are wet cell batteries, and those kind of wet cell batteries are not currently, like in the present we are not using those kind of batteries because of safety reasons, as you know. Now here it uses sulfuric acid, which is an acid which can damage people. And also, if we like our robots, we know our robots are mobile, so it will go and it might like bump, it will go in a like it it can go up and down. So with such movements the liquid can spill out, which will damage both the robot and the surrounding environment. So therefore these kind of wet cell batteries are no longer in use, I mean rarely in use. Instead we now use dry cell batteries. So inside a dry cell battery, what we use is dry components. Instead of these kind of liquids, we use dry components. So these are some kind of examples. Now this is a lipo battery which uses dry cells, dry components, and this is a newly built car battery. And this is this is the normal non-rechargeable batteries that we use. Okay. Then if we talk about rechargeable batteries, rechargeable batteries means the batteries which can be recharged and reused again. So those kinds of so mainly we can see three types of batteries: lithium ion batteries, lithium polymer batteries, and nickel metal hydride batteries. So we call these as NIMH batteries. So these three types of batteries we can use, then charge it again and use it again. So I believe you are familiar with this part, right? If you have used a phone, then if you have like taken a look inside your phone, you might have seen these kind of batteries. So this is a battery, this is a lithium ion battery. So these kinds of batteries we can recharge, you know, like if you, in your phone we use lithium ion batteries, so you can recharge your phone, right? Recharge your battery. So so what are the differences of these batteries, and what is the better option when we are building a robot? So lithium ion batteries are more suitable for applications with high capacity. So if you want to have a battery with high capacity, then most likable and most suitable solution will be lithium ion batteries. As you know, in our phones currently we have like I believe we even have 6,000 milliampere hours and even greater batteries in our phone, right? And also we know we have power banks up to 30,000 milliampere hours. So that is a very large capacity. So if we want such capacity, we can use a lithium ion battery. On the other hand, if you want to have a high current, okay, if you want to have a high current in your robot or other device, then what you can do is you can use lithium polymer batteries. So as you have seen here, this has like a crazy number of discharge rate, right? As when we have calculated this, we got 44 amperes. Now 44 amperes is a big number. So if you want a battery which gives such power and such current to your circuit, then what you should do is take a lithium polymer battery. So now the main one of the main differences that you can see in lithium ion and lithium polymer batteries is lithium ion battery has a hard case. Okay? I mean, like it's kind of a metal case, right? This is now in your phone battery. That's pretty hard. That's because lithium-ion batteries tend to react very fast. As you know, like in our phone batteries, we know with time our battery gets expanded, right? අපි කියන්නේ battery එක ඉදිමුණා කියලා. So that happens because of the reactiveness of the components inside the lithium-ion battery. That's why we need to have a metal enclosure. Otherwise, it might get it might expand and it might damage your whole circuit. So on the other hand, this lithium polymer battery is consist of a pouch. So like you can like touch and you can like manipulate the shape of this battery. So unlike lithium ion, lithium polymer doesn't react such so violently with the doesn't react so violently. So we don't need to use such hard cases. Instead, we can simply use a pouch for lithium polymer batteries. And this is a NIM match, or we say nickel metal hydride batteries. Now these batteries we don't use much anymore. This is very much safe than this is very much safer than lithium polymer and lithium ion. But the downside of this NIM match battery is its voltage. The voltage it can give is pretty low. Therefore, like if we want to use give me a minute. Give me a minute, I will be back in. Okay, sorry for the inconvenience. Let us continue. So what I was saying is these NIM match batteries, they don't have much voltage. So if we want to have like let's say 6 or 9 volts, then we need to connect like 6 to 8, I mean 5, 6, maybe 8 batteries to get such a voltage. So because of that reason, and also the power is very low. So because of that reasons, we normally don't use NIM match batteries. What we normally use are these lithium ion and lithium polymer batteries. So this is a simple comparison. As you can see, as I mentioned earlier, NIM match batteries have a nominal cell voltage of 1.2 volts. So if you want to have a 6-volt battery, you need to connect 5 of those cells to get such thing. 5 cells in series to get 6 volts. On the other hand, normally lithium ion and lithium polymer battery has a cell has normally 3.7 to 3.8 volts per cell. So you can simply connect 3 batteries and you can 3 cells and get 11.1 to 11.4 voltage using only 3 cells. So that's the power of lithium ion and lithium polymer. And these lithium ion and lithium polymer batteries come with like 3 different types mainly. One is high energy, then one is high current, and other one is high safety. So this high energy prioritize the energy of the battery. So high current prioritize the current. As you can see, it like has a 30C. And then high safety type prioritize the safety. So like as I mentioned earlier, that kind of like expansions and explosions are minimized in these kind of high safety batteries. So according to your application, you can choose your battery. So what are the pros and cons, so advantages and disadvantages of using lithium ion and lithium polymer batteries? Um, so what are the advantages and disadvantages of lithium ion and lithium polymer? Let's first talk about lithium ion batteries. So lithium ion batteries have a high power density. Okay, as I mentioned earlier, it has a high capacity and it has a high power density. So if you need to use a battery with high power density, the lithium ion battery is the one to go. And it doesn't have memory effect. So what do we call? So what is this memory effect? So it's like this. When you are charging your phone, do we need to wait until it gets dropped down to zero? I mean, do we need to fully discharge our battery before charging it again? No, right? It might be in 80%, it might be in 60%, it might be 0%. So at any state, you can simply connect your charger and charge your phone. Okay, so that is what we call no memory effect. So you can charge your battery at any stage and it won't affect to your battery. Okay, so that's what no memory effect means. On the other hand, lithium polymer has some memory effect. Okay, so you can't simply charge your lithium polymer battery at your will. You need to take some precautions. Then compared to lithium polymer, lithium ion battery is a low cost battery. So those are the pros of lithium ion. And on the other hand, lithium polymer batteries are robust and flexible. As I mentioned earlier, like we don't need to use like harder enclosures to in lithium polymer batteries. So they are very robust and flexible, and also they have low profile, and also they have a lower chance of leaking electrolytes. Okay, so that means there is a less chance of damaging your internal and external circuitry. And then if we come to cons of the battery, lithium ion can combust. As I mentioned earlier, it can damage your circuitry, right? So that is one disadvantage of lithium ion battery. And also it suffers from aging. So as let's take the same example, our phone batteries. We know that with time our phone battery suffers, right? It gets discharged very fast, and also it might not fully charge to 100%. It might sometimes stop at 95, 90, like that. So that is what we call as suffers from aging. Okay, and then the cons of lithium polymer is it's costly. Okay, so compared to lithium ion batteries, lithium polymer is costly and higher price, and also it stores less power, but it can give higher current, but it stores less power, and also it has a shorter lifespan. So those are the cons of uh, lithium polymer batteries compared to lithium ion batteries. So again, according to your application, you need to weigh down these pros and cons, and you need to choose what is the most suitable battery type that you need to use in your design. Okay, so like don't always go for higher options. Like you don't need to always use lithium polymer batteries for your applications. If it's if it doesn't want higher current, then you can simply go for lithium ion batteries. Okay, on the other hand, if you want like a higher current, then you might need to go for lithium polymer batteries. So always when you are now when you are building a robot, it's always about like balancing. When you considering to buy sensors, when you considering to buy batteries, when you considering to buy actuators, it's all about balancing. You need to compare the performance versus the price, and you need to make the better decision. Okay, so remember that always. And then, so how do we charge these batteries? There are mainly two types of chargers: regular charger and balanced charger. So what this regular charger do is when we plug it into when we plug our battery into a charger, it will charge. Okay, so it will give either constant current like that, and it will charge the battery. But uh, it might damage our battery. As I mentioned earlier, like this mostly happens to lithium polymer batteries. So as I mentioned earlier, lithium ion batteries doesn't have a memory effect. Therefore, we kind of can use these kind of chargers to charge lithium ion batteries and get away with it. But when it comes to lithium polymer chargers, we very much need to consider about the voltage that is given to the charger, and then the current that is taken from the charger. Those kind of things we need to be extra careful when it comes to lithium polymer batteries. Otherwise, it might get damaged. Okay, even like when we use a lithium polymer battery, we can't let it go down below a threshold value. Otherwise, we will not be able to get the highest performance from the battery from then onwards. Okay, so due to those reasons, we can use a balanced charger to charge our lithium polymer batteries, and so then we will be able to control the current that passes through and the voltage that is given to the battery. Such parameters we can control by using balanced charger. So obviously, balanced charger will be higher priced than a regular charger. So here again, you need to make a comparison and get a better option. Okay. So yes, that's it about batteries. I will be now handing over the session to Himanshi to do the voltage regulations, and thank you guys for listening.
Okay. Am I audible?
Yes, you are.
Okay. Today we are going to learn about voltage regulators. So basically, every product that runs on DC power needs voltage regulation. What exactly voltage regulation do? It takes a certain range of DC voltage and then it converts to a higher or a lower constant voltage. So why do we need to regulate? We use different components when we making a robot or we doing a project. So those different components need different voltage values to power up themselves. For an example, an Arduino board needs 5 volts and some sensors needs 3.3 volts, but some of the motors need higher voltage values to work. So a single battery cannot provide various voltage values like those. Therefore, we need a voltage regulator to match the voltage source with the component voltage requirement. These are some of the characteristics of a voltage regulator. It provides a stable and constant voltage input to our circuit and provides the overcurrent and thermal protection, and also act as a voltage conversion between the supply voltage and the voltage we need to power up our circuit. Earlier I said that the voltage regulator can regulate the supply power to a higher or a lower value. So these are the two kinds of doing that job. Here shows a buck converter which can drop the voltage down up to a certain value. So a boost converter is a step-up converter which can provide a higher voltage than the source voltage. There are buck and boost converters which are capable of doing both functionalities. Also, there are two types of regulators as linear regulators and switching regulators. Linear regulators drop down the source voltage to a certain value and release the rest of its energy as heat. So obviously it generates a lot of heat to the environment. But switching regulators rapidly switch the input voltage on and off and results an average value of the input voltage as the output. So depending on the depending on the switching frequency of the input voltage, various voltage, a wide range of voltages are possible from these kind of regulators. These are some of the examples for switching regulators. This LM2596 regulator is a buck converter which can drop down the source voltage to a certain value. Here you can see some of the characteristics. As I mentioned earlier, it can provide you a range of voltage, a wide range of voltages. It takes a range of voltages as the input, and we can we can adjust the regulator by turning this knob. So we can get a range of output voltages from this regulator, and it gives a maximum output current, and it's very efficient. So let's watch a video on LM2596 voltage regulator to clarify more about switching regulators. Okay. Now we have linear regulators. As I mentioned earlier, linear regulators drop down the source voltage to a certain value and release the rest of this energy as heat. This is the most commonly used linear regulator, which can regulate the source voltage to 5 volts. So, what the letters and numbers in this regulator mean? This first part, this 7-8 part, indicates the input regulator series, whether it
Recording in
supplied to our
progress.
circuit. Okay. Here you can see a LiPo battery indicator. When we are using a voltage regulator to get the required voltage, we do not have an idea about the charge of the battery we are using. So this LiPo battery indicator build a connection between the battery and the user. So that it indicates the amount of the charge remaining in the battery. This LED displays LED display displays the remaining charge of the battery. So this allows you to know when the battery is low, so that you will be able to charge your battery. So that's all for my session today. I hope you guys got a clear idea about voltage regulators. Thank you, and over to you.
Yes, thank you.
A big thank you goes out to our guest speakers for that eye-opening session. Now we'd like to open the floor for some questions. If you have any question related to the today's session, please direct them to the speakers today. There's one question from one of the participants. You may proceed. You can unmute yourself and direct the question to the speakers. It seems there are no questions regarding the session, so we'll move ahead. And that brings us to the end of the Q&A session. Let me now take this opportunity to thank Ranuri Gurusingha, Samidulianage, and Himanshi De Silva for humbly accepting our invitation despite their busy schedules, and for sharing us your invaluable knowledge on the topic of robotics. Please accept this digital token of appreciation for your contribution towards making this event a memorable one. Next up, this is for the participants. Please do fill in the feedback form of the event which we have shared on the chat, because your feedback helps us tremendously to improve in our future events. We will also give a certificate of participation to those who participate for all 4 days. And to this end, the feedback form will be what's taken into account when issuing the certificate. I would like to remind you to attend our next session happening tomorrow, which will be the last day of the workshop series. Now we have reached to the end of this informative webinar. Therefore, now I take the time to put our gratitude into words. I would like to once again thank our guest speakers, Ranu Rigurasinghe, Shamidhu Liyanage, and Himanshu De Silva for delivering a great session. And a heartfelt congratulations goes out to the organizing committee and the volunteers for all their hard work, which has made this webinar a memorable one for all of us. Next, our participants, without whom this session would not have been a success. Thank you for your enthusiasm and for staying with us regardless of any inconvenience occurred. So on behalf of the organizing committee, I must wholeheartedly thank the Students Activities Committee for guiding and working closely with us on this journey to make this webinar successful. Lastly, stay tuned on our social media platforms to get frequent updates on IEEE Techverse Sri Lanka and the IEEE Robotics and Automation Society of Wellassa University, as well as Circuit Breakers Robotics. Visit us on Facebook, LinkedIn, Instagram, and YouTube for more events and updates. Thank you and have a pleasant evening.